Hello, calculus students. Now here we're going to find the equation for the tangent line to the graph of f at x equals 1, where f is given by this function here. So the first thing I'm going to do is write the equation of a tangent line and point slope formula, because I'm given a point here, x equals 1. I can find y by simply substituting this point in for f, and then I can compute the slope by taking the derivative of f and then substituting x equals 1. You'll see how we're going to do that in a moment. I'm going to push the y1 over to the other side. Alright, now I have an equation for a line, and I can start computing each of these terms. I can compute the slope, I can compute x1, and I can compute y1. I'm going to start with the slope. So I need to compute this derivative first. So I'll use the product rule. 4, which is the derivative of this 4x, times this function left alone, plus 4x times the derivative of this function, and I have to use the chain rule on that guy. So the 3 comes down, I subtract 1 from the exponent, and then I multiply by the derivative of the inside. I'm going to clean this up a little bit. Because I have a minus sign over here. So 4 times 4 is 16, times 3 is 48. I have x, and then 3 minus 4x quantity squared. Okay, notice that we have some common factors here. This exponent is 3 and this exponent is 2, so the greatest common factor I can pull out is a 3 minus 4x quantity squared. So let's do that. And I can also pull out a 4 from this term and a 4 from this term, which would leave me a 12 here. Okay, so let's simplify this a little bit. Alright. Oops, and I can pull out a 4, I said. Alright. So now, let's write down what was left. There is a 3 minus 4x left, because I pulled out a squared from, so I pulled out a factor of 3 minus 4x quantity squared from this term here, so that leaves one of these exponents. And then I pulled out a 4, so that leaves me with a minus 12x, and that's all that's left from this term, because I factored this term out. And that is it. So now I can just simplify this a little bit more, and that'll just make my computations a little bit easier. So I have 3 minus 4 minus 12 is minus 16x, and I'm just going to leave it like that. Okay, so the slope is the derivative evaluated at this point, x equals 1. So I will substitute that in. So I'll plug the 1 in, and then do a quick simplification here. So 3 minus, let's see, I have order of operations, 4 times 1 is 4, so 3 minus 4 is minus 1, minus 1 squared is 1. So I have 4 times 1, 3 minus 16 is minus 13. And so that implies that the slope is 4 times minus 13, which is minus 52. All right, outstanding. So let's go back to our equation of the line here and recall that I have just about all the information I need. I have a minus 52. I have x minus 1 because x equals 1. And now I just have to compute y1, but that is just simply the function, the output of the function, given this input, x equals 1. So I just have to simply input 1 into the function to get the y value. And if you want to simplify that, you certainly can by just hopefully doing some simple arithmetic. So we have 3 minus 4, which is minus 1 cubed, and that gives us a minus 1, and so that gives us a minus 4. And we can simplify this further and put it into point-slope formula, but this is a perfectly reasonable solution to our problem. All right, good luck.